My name is Joseph Wunderlich. I'm a professor of engineering, architecture, and computer science. This is a quick summary of a lecture that takes typically 75 minutes in a classroom. It could take 2 or 3 lectures if we stop and read everything and discuss everything. I'm just going to quickly go over it here as fast as possible to give the students an overview. So this is thermodynamics in buildings using our textbook, and we're going to emphasize conduction, convection, and radiation in heat transfer, as well as other principles in thermodynamics. And firstly, just defining sensible heat versus latent heat. And the students should read through that and what temperature means. And then conduction and how that applies to buildings. And particularly in chapter 15, we're going to be looking at R values and the resistivity. So with latent heat, people want to understand the 3-phase diagrams and how those work, and sublimation and what that means, transferring between states of liquid, gas, and solids. And more clear diagrams to read here for water. And then with convection and heat transfer, understanding how that works in buildings and stratification and the details there. Evaporative cooling we want to talk about, blowing air over the surface of the human skin and trying to get that naturally if we can with passive design, and then also with active design we'll talk about in later chapters. And then thirdly, with heat transfer, radiation, which is a form of electromagnetic radiation, which is heat transfers as it radiates from sources and off of the human body, and just talking about that and how light is a visible band of electromagnetic radiation and different types of interactions with heat and any kind of electromagnetic radiation, but heat is what we're talking about here mostly. The greenhouse effect and how that works on the Earth as well as in buildings. Different types of materials and the balance between absorbance and emittance with different coatings and how to design for that in different climates. Mean radiant temperature, so what it feels like at a point within a building based on the openings and the transmittance of heat through the walls and ceiling, and also sources of heat, fireplace. Ways to stop the flow of heat out of your building with weather stripping or into your building. The trade-offs when we're designing during COVID times and other times of the air exchanges that typically you would get in a house or any kind of building design, commercial, residential, industrial, versus how much air exchanges are recommended for COVID. Details about COVID, we're certainly not going to go into this now. We've spent a couple of years looking quite a bit in classrooms. Again, we'll talk more about this in the class. But transport of different diseases and particulates, and ozone, air pollution, all through the movement of air, asbestos, mold, more on mold, design for mold, preventing mold in different spaces in the building. Again, we'll go through much slower in the classroom. This is a quick overview. Lots of details on mold, more on COVID and particle sizes, and the fact that it is an aerosol. It does spread as an aerosol with peer-reviewed research showing that in the Journal of Medicine. COVID particle sizes and the type of masks that people talk about and are specified at different times. Cloth masks versus the KN95s or N95s, and then HEPA filters that you don't see in face masks, but this would be in a building for the best of filtration. More on COVID and design specifications for buildings, recommendations. And then some other things in energy conversion and transmitting power, loss, I squared R losses, energy, combined heat and power techniques, hydrogen fuel cells. These are all mentioned in this chapter in the book. And here is a methane digester, which would be an alternative to the hydrogen fuel cells here. We're using methane made naturally from cows into a digester with a complex chemical digestion process, and then end result electricity that we could use. We're in a farming area right now in Pennsylvania while I'm making this lecture, and this could be a common thing to do here. And a summary of the trade-offs of balancing, designing for a tight envelope in a building, but also allowing fresh air to pass for general health, but also certainly during times we're dealing with a pandemic.